Okay.
Or is it visible?
What?
The screen is visible, the board.
Yeah. Yeah. It is. It is.
So we'll move on to the textbook again. Okay. So this was generally the problem that we were discussing in the last class in the morning.
Yeah.
Okay. So see, this is the distribution that he has given. See, so he has drawn more minutely. Means what? He has taken the scale. He has taken the scale in the graph. Scale can vary from person to person. It is not fixed. So as we have taken 1 centimeter on y-axis, huh? I'm talking about y-axis. As
Yeah.
y-axis, 1 centimeter to be 1,000, correct? Our graph starts with 1,000 count. Then we increment every step by a addition of 1,000. Same in his graph, he has taken a minimum range of minimum step of 500. So his first centimeter is 500, second will be plus 500, that's 1,000. Thirds will be 1,500, likewise. So no problem. It doesn't matter the scale, the matter is how you have drawn out the graph. Okay, so see, to make the bar graph, what
But
we
did I
have
make
to
that?
do. No, 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 we don't have to make that. You have made, that's enough.
Oh.
So to make the paragraph, draw and label the axis. How he has done it here. Label the axis, okay? Both the axis. See that this name also matches radio to station format and number of stations. So scale the axis. Scale the axis means writing the numbers, the range on it. The largest frequency is 4852. I told you the largest is 4852. So our maximum count in our graph should be 5,000. Okay, no? Because we have to plot 485 middle value. So it should be 5,000. Whether we are plotting in 500 scale or in 1,000 scale, 5,000 should be a
Yeah.
maximum value. So draw the bars according to the category names. Okay, come on. Next, we'll move on to the next thing. This is the pie chart. Okay. So, okay. What he has done in the pie chart, again, how he has converted the chart into frequency. I'll take the table here once. Just
Oh, wait, can you give me a minute real quick?
give you a minute.
Yeah.
Okay, yes, yes, you may take.
I'm back.
Okay, Zaid. I'm also here at this
Yeah.
end. Okay, so I'll
What?
take this table and show you how to draw the pie chart. Same, so it will be very clear when we'll revise it two times. Okay, I'll take this table.
Mhm.
So as yesterday I had created, the first step is to create it into a relative frequency. So first of all, we'll copy it here. Okay. So Zaid, what's the total of it? In relative frequency, what we have to do is we have to divide each quantity by the total. Each quantity, each quantity by the total. So 2, 5, 3, 6 divide. Just I'll give you the general idea. I'll not do the whole thing. 2, 5, 3, 6 divided by the total quantity. That's 25,452. Correct?
Yeah.
Okay. So when I'll divide this, you'll see what the calculator gives us. Let's see. So 2, 5, 3, 6 divided by 2, 5, 4, 5, 2. It's 0.000.09638. 0.999963 means I can write 0.996. So this is the relative frequency, RF. So what I have to do is that this relative frequency, I have to convert this into degrees. So I have to multiply it by a number so that it converts it into degrees. So in this pie chart, which is of 360 degree, I'll explain again 360 degree. I have to find how much one radio station, one radio station represents how much degree, how much degree. So for this, what I have to do is I have to generally divide 360 to the 360 degree divided by 25452. So what will be the answer? We'll just check. 360 divided by 25452. The answer is near about 0.01414 degrees. 0.1414 degrees. So I have to multiply 0.1414. Then I'll get the answer in degrees. How much the first radio station will represent in the chart. So we'll just see how much it is. So 0.0996 into 0.1414. So sorry. So I think I have done something wrong here. Okay. Sorry. That's a mistake here. So we'll divide 25,452 by 360. We have to find the degrees, na? So we'll divide this thing. So it will be 25,452 divided by 360. So it is near about, we'll have to multiply it by 70 degrees. So it will be 0 point, which is, I can say, 996 into 70. So it will give us 69.70. So this will represent 69.7 degrees in the pie chart. So what will be the first task? Draw a circle.
You
Then,
you put 0.99 cents, not 0.099 cents.
oh, sorry. Okay, 0.0996 into 70. Is 70 correct? 70 degree. So it is 6.97. Okay, 6.97. 6 point, I'll correct myself. 6.972. So I'll take the product term, measure 6.97, and where it comes, this region will give me the first radio station, the data about the first radio station. Is it understood what we have to do, Zaid? Generally, for the pie
Yeah,
chart? Take out each relative frequency for each individual 1274 upon the total 25452. Then this is the relative frequency. Then we have to convert it into degrees by multiplying by into 70 degrees. Okay. So this will also be
yeah.
a homework for you to do this. So we'll just see it in our textbook. How he has done it. It is the same way. So our first adult content is 10%. This is all sports 5%. He has converted into around adult, see, 2536. He has converted round off. He has done the round off of it. 10% he has given here. He has done the round off. Okay. So this is how a pie chart is represented here. Okay. Note that a pie chart must include all categories that make up a whole, which might mean adding on other categories, as in the radio station example. Okay. What he has done as to make it other also, he has taken the other category. He has not missed the other category. See, he has included the other one also. It should contain all the individuals in the pie chart. We cannot miss a single individual also during a pie chart, or it will not be complete. Okay, now read this problem page on your screen.
7 famous,
Someone,
7 famous.
okay, you'll use famous. I'll just read it. The American Statistical Association sponsors a web-based project that collects data about primary and secondary school students in a survey. Use the site's random sampling to choose 40 US high schools students who completed the survey in a recent year. One of the question asked, which would you prefer to be? Select one. Rich, happy, famous, healthy. Someone famous. Okay. Here are the responses from 40 random selected students. Okay. So the students, 40 students in USA, take this problem also.
I need to get some water real quick.
What you are telling?
I need some water real quick.
I
I
didn't
need to get
understand.
some water.
I said, okay, you need some water.
Yeah.
Okay, drink it. No problem. Drink the water. I'll also drink some water and get back. Are you ready, Zaid? I'm ready at the end. As soon as you are ready, we'll start.
Okay, I'm back.
Okay, I'm ready at this end also.
What?
Yes, I'm ready here also. So first of all, what we'll do is that we'll make a table of it as we have to record as we have to plot this, make a relative frequency bar graph of the data. So what we have to do is make the relative frequency bar graph. So we have to make a frequency table here. So I think there are 40 students. So for suppose to the Americans. There are 40 students. Okay. So I'll take the students who have chose famous. One is the famous thing. Okay. How we draw. See, how we draw a frequency table. We write down the categories here. Okay. Categories. What are the unique categories? That's famous. Okay. Happy, happy. Then rich and healthy. Rich and healthy. So this is the observation, this one. You're listed in the table for the 40 students. Okay. So we'll first tally it, tally, tally, then write down its frequency and write down its relative frequency. I've told you relative frequency is required for the pie chart. So tally, famous. See, how many is there? One, then two. This is one. This is two. This is three. This is four. This is five. This is six. This is seven. Okay, so how many is there? One, two, three, four, five, six, seven. So the frequency is seven. We don't know total, but we'll calculate the total. Yes, we know total. The total are 40 students. So the relative frequency will be 70 divided by 40. How much it is, you calculate. Okay. Now next, happy. Can you count, Zaid? How many happy students are there? How many students have chose happy? So it's one, two, three, four, five, six, seven, eight, and it's nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. See, you're 20 students, so I'll not draw all the things, lines. I'll write 20, 20 as chosen. Now, rich is how many rich? One, one, two, three, four, five, six, seven, eight. Eight are has chosen it. One, two, three, four, five, six, seven, eight. So it will be eight. So let's say frequency 20 upon 40. So it is near about 0. It is exactly 0.5 here. So this is 8 by 40. I think this is
What's
exact.
the
Yes,
20?
yes,
Yeah,
correct.
20.
20%. Yes. And healthy is how much the left one is healthy. So I'll just count once healthy that we have calculated other
5.
things correctly. One,
5.
one, two. Wait a minute.
5.
Two. It's five. You have counted it.
No, I look at what's left.
Yes, 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 yes. I know that. Just I am. Okay, we'll
There's
take it.
40.
Okay, five.
There's
So it will
40 and there's
Correct. 5 upon
5 left.
40, 0 point, how much it will be? 1, 1, 5 divided by 40 is 0 0.1, 2,
6 5.
2,
Okay.
5,
1
1
to
to
5.
5. Yes. So what will be the left frequency of this? I think so. 0 0.5, this is 0 0.2, this is 0 0.125. So for 7 divided by 40 is around 0 0.1. 30 will be left 0 0.7 and 5, 0 0.15.
5.
Yes, done. Correct? So,
Yes.
so what was the question? See, I've drawn the frequency table. Here are the categories. Okay. Here I've done the tally in this column. Here frequency and relative frequency. So now make a relative frequency bar graph of the data. Describe what you see. So I'll draw the relative frequency here, bar graph. By relative frequency, I have to draw the data, not by frequency. So, so it's very important that, okay, so here I'll write a category. So category is, first is famous, second one is happy, third one is rich, and the fourth one is healthy. So it will be relative frequency here, RF. I want to plot category with relative frequency. So it will be 0. I will start 1 centimeter 0 0.2, 0 0.2, 0 0.4, 0 0.6, 0 0.8, and 1.0. You know, all the addition of this will come 1, not more than that. So 0 0.2. So what is for famous? It's 0 0.175, means near about to 2, 0 0.175. So it will be like this. Correct? I should draw it more smaller, I think. So this 175. You can start the scales from zero point 0.1 also. I'll draw both the graphs with both the scales. Okay. So this container is for famous and its ranges below zero point 0.2, near about 0.175. So next for happy, it's 0.5. So it will be in exactly between this. So I'll draw the graph and color the bit. So now for rich one is 0 0.2, exactly this year, and this is 0 0.2. Now healthy is 0 0.125. So it will be exactly half of this and above it. So it will be like 125. So it will be like this. Smaller than, it should be smaller than this. So this is the relative frequency bar chart. Relative frequency bar chart. Once more, I'll draw it with a zero point 0.1 scale. Means what? I'll show you. What is meaning of scaling or setting different scales. Here is famous. Here is healthy. Here is, what is this? Happy, rich, and healthy. Healthy. And this is happy. Okay, I'll set the scale as zero point 0.1. So 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6. Okay, I had to go till 1, but I'll stop here. You can go till 1, not a problem. So what is for famous? 0 0.175. See, 0 0.15 will be here. Just above it will be 0 0.175. So my bin will come here. Then for happy is zero point 0.5. So my bin will start, go to zero point 0.5 and then come back. So you will draw more with linearity. Then there is rich, so it's zero point 0.2. So this is the marker here. 0 0.2 bin will come here. Now the next one is 0.125. So 125, it will be exactly above 0.1. So this is 0 0.1. Is it clear there with different scales what I have
Yeah.
plotted here? Okay, okay.
Yeah.
Now
Yeah.
we'll move on to the next graph. So now what next definition we have to see? Graphs good and bad. But bar graphs are a bit dull to look at. It is tempting to replace the bars with pictures or to use special 3D effects to
Yeah.
make the graph seem more interesting. Don't do it.
Mm-hmm.
Our eyes react to the area of the bars as well as to their heights. When all bars have the same width, the area into, okay, that's not for our use. Okay, so first of all, we'll see something. See, what you can discover from this graph is that the highest the students have chosen from the graph, you can see that they have chosen to be happy more than to be famous. Then the second highest is to be rich. Then the third one is to be famous, and the least priority they have given is to be healthy. But health is wealth matters. Health matters the most. There may be a million and billion of dollars with you, but if there is no health, then it is of no use. I think so. So health matters the most. Then famous and rich and happy. Happiness also matters the most. Happiness also matters the most. Okay, come on. We'll move on to the next sum. Okay. So shall we do the sums or shall we start the next topic? What would you suggest? You'll do these sums,
Uh,
right? Okay, okay.
yeah,
So
I did yeah, did the thing, yeah.
so we'll start the next topic. That's two-way table. We were drawing one-way table. See here, it was famous, and we were listing or tallying it according the this whole row was representing famous, and it was representing the attributes. These columns were representing the attributes of famous. What does famous tells us? What data famous has collected means. In the name of famous, what data do we have? So this row was telling us that. But in a two-way table, what's a two-way table? A two-way table is a table of counts that summarizes data on the relationship between two categorical variables for the sum group of individuals. Yes, yes, yes. Coming back, I've told you. Yes, in the morning also, the table we were studying earlier was one one categorical one categorical table in which we were listing a category here and then marking its frequency here. The categories one, two, three, four, and its frequency that it's coming is here. So this was a one-way table because there was one category in this column and we were comparing it to the basic frequency. But what is a two-way table? A two-way table is a table of count that summarizes two categorical variables. See here, two categorical variables. What are the two categorical variables here? Snowmobile use and environmental club. Means what? We'll first read the one upside this. Or yes, I think so. Okay, he has given it here. Okay. So you have learned some techniques for analyzing the distribution of a single categorical variable. Yes, we have learned about this. Till now we were learning analyzing data on one categorical variable. Now we are starting for two categorical variables. What should you do when a data set involves two categorical variables? For example, Yellowstone National Park staff surveyed a random sample of 1526 winter visitors to the park. Means they have surveyed around 1,500, 1,526 winter visitors to the park. They asked each person whether he or she belonged to an environmental club. So, what will be the answer of an environmental club? It will be a category. It will be a binary, yes or no. Binary answer. If he belongs to the environmental club, he will say yes. If no, then he or she will say no. Okay. So ask whether they owned. Okay. The second question that they asked was respondents were also asked whether they owned, rented, or had never used a snowmobile. The data sets look like something like the following. So, what is the main thing? I'll explain you here what they have done, how they have. The main thing is to see that how the table is made. It's very important. So, down here. Okay, so what they have done is they have listed environmental club here. So environmental club. So what an environmental club is in the what you may say, the vertical direction, vertical one. So what are the outputs of the environmental club? Either yes or either yes or no. Correct? Right? Are you there, Zay? And I'm
Yeah,
unable.
yeah, yeah. I'm there. I'm there. I'm there.
Yes. Okay. So either the output of environmental club is yes or either no. So and what's the output of snowmobile? So if I am for suppose snowmobile, this is my column. So it is either own, rent, or they have never seen. Okay. So we'll count. Likewise, see you're in the data set. He has counted this is our data. So we'll count how much of them are never seen. So it is 445. Both the categories should match. They should have owned the snowmobile as well as they are a member of environmental club. How many people are there? 445 with both the attributes. What are the two attributes? That they own a snowmobile as well as have they are a member of environmental club. Correct? Right?
Yeah.
Yeah.
Yes.
So now the next is they own. Oh, sorry, I've written own first. Huh? In that table, they have written. So the number is two. Own is 279. 279. We can draw the table up. How anyways we can write the name of the column. So how many with the attributes they okay yes okay sorry yes is listed there. So,
What? Okay.
no. See, own and yes, we can see in this column here there are 16. So I'm just correcting the number. Own and no, both with both the attributes are 279. So it is 279. So next, rent and no is 497. 497.
Yes.
And next, rent and yes is 77. rent Rented a snowmobile and also they are a member of environmental club. And then the last never and no is 445. Never owns 445 and they are not a member of both club. So never and yes, it's 212. So what was the general task is that in the table when the table was in front. So what we have to do, we have to pick up one attribute of the snowmobile. Owned, so I'll check owned. Now in owned, I'll see environmental club. There has two entries, no and yes. So for owned one, who has owned, I'll check for the yes one. So the count when I checked, which is owned and also is yes, so the count came to be 60. Do you understood this? How we'll count it in the table?
Yeah.
Yeah. So this is how
Yeah,
the
I
table is
understand
formed.
that. Yeah.
Yeah. So this is how a two-way table is being represented. So this is the total. See, we do total column-wise as well as row-wise, both. This total, it would come to be 305. 305. Next total will be 1221. Here, if we do row-wise, then six. If we do
Mhm.
row-wise total, it would be six. Here, three rows are there, two and three. Okay. It would be own is for own 295, 295, 295, 295. Okay. Range 574, range 574, and it's 657. And the magic that you'll see is that when you add these two quantities, okay, add these two quantities and add these three quantities also, the total that will come addition of these two with the addition of when you compare the addition with this three will be the same. That's 1526. And how many customers they had? See here, how many customers were there? Just 1526 were there.
1,500.
So
Yeah.
126. So the total will come 1526. It's an attribute of course, it's an attribute of the table. Okay. So have you understood uh,
Yeah.
how to calculate it? Okay. So
Yeah.
if we want to calculate the relative frequency, relative, what you may say, relative frequency that each variable is holding. So see here, he has done it. If I want to calculate that how many environmental club members have said yes. So it's 305. So what I'll do, 305 divided by 1526. So I'll get 20%. What this 20% represents, I'll just take this table here. It will be very helpful to understand. Does it represent? Very important to see it. See, what does it represent, this 20%? 20% what we have calculated when we are saying about environmental club members, and it is 305. So what we have done, 305 divided by 1526, so it came out to be 20%. So this 20% represents that 20% members of were of environmental clubs. So if I am telling how many member, how many percentage, in percentage, tell me how many were not members, how many people were not members. So there are generally two categories, yes and no. Yes came for 20%, so no will come for 20, 100 minus 20, that's
80%.
80%. Correct?
Yes.
Yes, this is how relative frequency. So when we'll draw a bar chart or a pie chart, we generally don't do this so for two categorical variables when there is a binary output, but I'll show you. So for example, it is zero point 0.2 and for example, this is 0.8. So for yes, my bar would be like this somewhat here, and for no, it would be somewhat here. Understood?
Yeah.
This is
Bigger
how it is.
different.
Pie chart also. Pie chart, I'll make this 20% here, and the left area, this area would be 80%. 80%. Now we'll move on to the next question. Okay, downside. Marginal relative frequency. It is very important, this concept, marginal relative frequency. A marginal relative frequency gives the percent or proportion of the individual that a specific value or one category variable has. Means what? When does marginal probability come into picture? This is very important to note it down. When does it come in picture? Just a minute, that I'll start. Just a minute. I'll get back.
Yeah. Yeah. Huh, that's odd.
Okay, then. Coming back to marginal marginal frequency, marginal relative, marginal relative frequency. When does marginal relative frequency come into picture? When we are comparing, when we are comparing two categorical categorical variables in one table, in one table. So marginal means when I am seeing here, this is in this table we can calculate the marginal probability. So what I'll do, I want to see that what is the margin of snowmobile with yes and as well as no. So what I'll do, 547 divided by 1526. So it will give me the marginal probability of snowmobile use with yes as well as no. So we will see here what he have done. See. So we can compute marginal relative frequency for the columns totals. Column totals, I've told you. This, I can calculate marginal probability for this, for this, for this, correct? There are three columns as well as rows totals also. These are the row totals. These are the column totals, this two. and this is the row total. So I'll erase it once. Then how he will go through will go. So he has told that we can perform marginal relative frequency. We can calculate for the row total. That's 121, 1221, and 305. We have seen this is 20% and this is
Stop.
80%. We have calculated it, correct?
Stop, Zaid. Stop.
Hello?
Yes, you are there?
Yeah, I'm there. I'm there.
Okay.
I couldn't hear you
So
for a second. Yeah.
uh, the moment you are unable to hear me, you should respond to me that, sir, I am unable to hear. Okay? Right?
Okay. I
Then
got
we
it.
okay. So see here, this is the row wise marginal probability. Row wise, yeah, column wise. This is the column wise. Column wise. This is the column wise. Okay. And this is the row wise marginal probability. Have you understood this? What he has done? See, level
Roll.
has six total
Mhm.
number of 650, total 657. And what total number of customers we have? 1526. So it came to be 43.1%. So this is how
Yeah.
we had to calculate the marginal relative frequency in a two categorical variable table. Here, this is 20 and 80. This is, I'll write the marginal for 657 is 43.1. For 657, it is 43.1% relative frequency. For 4574, it's 37.6%. And for snow mobile owner, it's 19.3%. 19.3%. Is it correct? You got it?
Yeah, I got it. Yeah.
Okay. Okay. Now know that we could use a bar graph or a pie chart to display either of these distributions. A marginal relative frequency tells us about only one of the variables in a two-way table. It won't help you answer questions
Yes.
like these. Means uh, if we are drawing a bar chart, if we are drawing a bar chart, like what I've drawn here. So what does it tell me? It tells me about EC, Environmental Club, is a member or no? Does it tell me about the owner of the snowmobile? No. This bar chart, does it tell me that the person belongs to the owner of the snowmobile? Yes or no?
No. No.
No, because it doesn't have a category listed down here. That's the reason he cannot tell me about the snowmobile owners. So in a bar chart, it is difficult to represent uh, two categories. So what we will learn now, joint relative frequency. Joint relative frequency, you can mark the definition. So a joint relative frequency gives the percent or proportion of individuals that have a specific value for one category variable and a specific value for another category variable. So what we'll do is you can see it here. See what we have done. Joint frequency has performed it. I think here. Okay. See, 16 divided by 1526. 16. 16. Yeah. What we are doing here is that we are calculating the frequency, what you may say, the percentage of single entries. Likewise, I have to calculate the number of people, the percentage of relative frequency for never use and no. Never use and no. I'll divide here. We have it on the table, correct? Yeah. Okay. So I'll divide 445 or 445. I want to know this. So I'll take 445 divided by the column total. What is the column total? That's 657. Understood, Zaid?
Yeah. I'm there.
Yeah.
Mm-hmm.
So see how he has done. Downside. Yes. So 445. Oh, we'll divide it by the total number of observations. 445 divided by 1526. 1526. So it will give me the relative 1526. So what it will give me? Joint relative frequency. Joint relative frequency is of 2. Specific value we have calculated here. specific value for a one categorical variable and a specific value for another categorical variable. So I can divide 445 like this also. Understood? We can calculate for a single category also. So now next, I'll give you an homework is this example. Don't see the solution. I'll suggest you go with it, or we'll shall solve this example. Okay. So read this problem.
Mhm.
Just read it. Yeah, right. Just a minute. I drink water. Okay. So what are the questions here? First, we'll see to it. What proportion of adult passengers on the Titanic survived? So what is the first? I'll take this one there. Okay. What proportion of adult passengers on a Titanic survived? He's asking me proportion. What does proportion mean? Quantity of survived upon total number of passengers. We get a general idea. Total number of passengers, survived passengers upon total number of passengers will give me the proportion. Will give me the proportion. So how many is the survived passengers, right? So he has not calculated
442.
the total. Oh, you have done the total.
The total amount who survived is 442.
442. Very good. So 442 divided by how much total number of what are the total number of passengers there? You
Wait.
have what you have to do is that I have sum you have summed this survived row. You need to sum this died row also. So it will be I'll open the calculator.
So 442 divided by 1,207.
122 plus 167 plus
36.61%.
oh you have mashallah you have calculated percentage also. Good, 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 good. 122 plus 167 plus mostly mobile calculation or mobile calculator perform more better. Better means easy to use. So the total is 7 0 and it's 12 1207. So correct, total is 1207.
Mm-hmm.
Yes. So this is the proportion of the passengers survived. So next question is find the distribution of the class of travel for adult passengers on the Titanic using relative frequency. So what I have to do is adult passengers I have to calculate, na? For the adult passengers, distribution of the class of travel. So what I'll do, I have to plot a distribution, means a bar graph or a pie chart. You can use anything. Okay. So for what I have
Yeah,
to
okay.
plot class of travel. My categorical will come here, class of travel, and my bins is for first class, second class, and third class. Okay, and I have to
Mm-hmm.
plot it using relative frequencies, RF. So it will be 0 0.1, 0 0.2, 0 0.3, and 0 0.4. Likewise, we'll go till one. Just I'm giving you a rough idea. You have to do this exercise as homework. So I have
All
to
right.
calculate the class of travel. So what I need to do is that total this two. It will be 319 divided by total. That's 1207. So I'll get the relative frequency of first class. I need to see the homework tomorrow. Tomorrow, before the class. First class. Okay.
Uh,
So this you have to
I
plot it. You got
I
it?
already got it.
122. Okay, okay, okay then. Nice.
Oh, yeah. It
Mashallah, you
is
are a good learner. Good learner. Mashallah.
yeah,
So what
it
percentage of
is
other yes, what percentage of adult Titanic passengers traveled in the third class and survived? So there are two
uh
attributes here. The percentage of
is
adults that traveled in the third class while seeing to the third class first, then survived class. So it is 151. So what how we'll calculate the percentage? 151 divided by the total 1207. When we'll divide it, we get the percentage. Yes or no?
Yeah, the second one is 26.42%,
Yes, correct.
and
Correct.
the third one is 4.5%.
Correct. Good. So you need to plot it and show me tomorrow. So now we'll move on. We'll see what's the next topic here. So C has listed it here. Okay, so next is also a problem. You can try this also as a homework. If you not get it, we'll see. Okay, then relationship between two categorical variables. We'll start it tomorrow. Okay.
Mhm.
Okay, so
Yeah,
we'll stop our class here. You need to, I must see your homework on my WhatsApp, this sum, as well as this. Check your understanding. This sum also needs to be done in homework. Is it clear? The homework is clear?
yeah, got it.
Okay, sir, come on. Thank you very much. Bye. Assalamu alaikum.
Yeah,
You can leave now.
walaikum salam. Mhm.